Hi kids, till now we have seen the subtler aspects of matter. Let us look at matter in a different manner today. Let us see what we are going to learn in this particular video. We'll try and understand what is matter, that matter occupies space, that matter has mass, that matter is made up of tiny particles. These tiny particles have space between them. These tiny particles are in constant motion, and that these tiny particles are attracted to each other. In order to understand what is matter, we need to look at few examples in our daily life. Here's a flash of light, an apple, a kid waving, a bicycle, sound from speaker, and lightning. So among these, if I ask you to identify objects that occupy space and has mass, what would those be? Is it light? Can you measure the mass of light? No, right? What about sound or electricity? You can't measure the mass of any of these, right? So what are left behind? You have an apple, a bicycle, and a human being. So these are the ones that occupy space and has mass, correct? So such substances in general are termed as matter. So what about the rest of the examples? The rest of the examples belong to energy. In general, anything in this universe are either energy or matter. Now let us see whether matter really occupies space. Next time your coffee or tea overflows, remind yourself that it is happening because the space is already occupied by the liquid you previously poured into the cup. Now for the Eureka moment. Archimedes has proposed that when you immerse a solid into water, the volume of the water spilt is equivalent to the volume or the space occupied by the solid. Thus, we can confirm that liquid and solids occupy space. Now, what about gases? Do they occupy space? Yes, they do occupy space. When you pour water into a bottle, you are actually displacing air inside that bottle. How do you confirm that there was air in it? You may ask. Next time you dip a bottle or any container inside water, observe the air bubbles coming out. Where was it before? Wasn't it in the container? All the previous examples showcase that matter occupies space, and it really doesn't matter whether it is solid, liquid, or gas. Over here, you can see that a kid is stuffing a glass with a wad of paper and it is being immersed into water. Look at the way it is immersed into water. It goes straight down, making sure that no air is lost from the glass. The kid over here is surprised to see that the paper is not wet at all. Let us see why. When you place a glass containing a wad of paper inside water, it so happens that the air that is occupying this glass will not allow water to enter it. So therefore, the wad of paper remains untouched by water. So it is still dry. In case if you tilt the glass, letting air escape from it, the water will be allowed inside. Hence, it will wet the paper inside it. This proves that air occupies space. Now let us try to understand that matter has mass. Here you can see a jar of marbles. Each marble represents a tiny particle. Just like this analogy, even matter is made up of tiny particles. If we consider one marble to be 1 gram and we have 10 marbles out here, the total mass of this particular matter will be 10 grams, correct? If we have one marble equivalent to 4 grams, it will be 40 grams, right? So what I'm trying to say is that the total matter in this particular substance is its mass. And if you keep adding more and more tiny particles, you're basically increasing the matter, right? The amount of matter. As you increase the amount of matter, you are also increasing the mass of that particular substance. Also know that mass and volume are entirely different. Volume is the space occupied by that substance, whereas mass is the amount of matter in that particular substance. Let us look at few examples. Here you can see that there is 1 kg of iron and 1 kg of cotton. Though they both weigh the same, their volume is entirely different. Let us look at another example. Here, the volume of all the three matter or substances are exactly the same, right? But they are made up of different materials: charcoal, glass, and copper. So, because they are made up of different materials, their mass will also change. So it is 16, 25, and 87 grams respectively. So mass and volume are entirely different from one another. Let us try to understand mass a little better by observing the three types of matter given out here. Observe that matter A and B are more compactly arranged when compared to C, that matter B has the most number of particles and matter C has the most heavier particles in it. Even after considering all these, when you try to find out the mass, you find out that the mass of matter A is more than matter B and matter C, owing to the number of particles present in it and how heavy the particles are. Basically, mass depends on the number of particles in a substance, how compactly they are arranged in a given volume, and how heavy each particle is. Now let us see whether particles of matter has space between them. Observe the level of water before and after the dissolution of salt, the common salt or the sodium chloride. Doesn't it remain the same? What can be the reason for it? The reason is the space between the water particles. The common salt is made up of many tiny salt particles which dissociate in water and takes up the space between the water particles, thus not increasing the volume of water or the space occupied by water after the dissolution. But as the particles are very tiny, we can't physically observe this. This example emphasizes the fact that matter is made up of tiny particles and that it has space between them. Next, we can see another example which is similar to the previous one. Here, instead of salt or common salt, we are going to take potassium permanganate. In here, a few crystals of potassium permanganate salt sheds light on another aspect of matter. Look at how 10 ml of solution is further diluted with 100 ml of water. Even after at the end of such serial dilution, the color of water is still pink. This indicates that there might be millions of potassium permanganate particles in a crystal of the same. Hence, the size of these particles are small beyond our imagination. Now let us look at the fact that particles of matter are in constant motion. What do you think will happen when you add a drop of ink to a glass of water and let it stand undisturbed for a while? Let us see. Didn't the ink diffuse and spread throughout water? What caused it? Who stirred it? The best explanation for this is that the particles of matter are in constant motion. Hence, the moving water particles help the ink to diffuse throughout. Now let us look at the fact that particles of matter attract each other. Particles of matter attract each other and try to stay together, and that is called as cohesion. This property can be seen when you try to break the stream of water coming from the tap. Something similar can be seen here too. Here you can see water molecules follow the previous water molecules along the thread. Some particles are more attracted to each other and some are less attracted to each other, which you can observe here. Chalk particles are easier to break because they are less attracted to each other, which isn't the case with the iron particles. Now let us recap what we have learned till now. Any substance which has mass and occupies space is termed as matter. Matter occupies space irrespective of its state. Matter has mass which isn't dependent on the volume. Matter is made of very tiny particles and they have space between them. Particles of matter are in constant motion. Finally, particles of matter attract each other. Thank you.